So I'm going to record this, but I'm only going to put it on our Facebook group, and that's private. So we are recording, and that's okay. Before we start, I want to make sure you see this good news here. Pushed back the due date. The take-home test was due Friday at midnight, and 1.6 was due Sunday. Well, I moved them both back 2 days. Mainly because I'll be camping and I will not have access to any Wi-Fi, hardly any Wi-Fi, maybe a little bit this weekend. So I won't be able to help. Still kind of messes you up on the take-home test, but I will be back in town by Sunday at about 5-ish, I think, probably. All right, so there's been a request to look at number 16. Now I have all these on here, and you should have your take-home test in front of you. Should have a paper copy of it. If not, if you don't have that yet, I checked last night, I still had some copies in my box on my front porch. Don't go right now, but not right into the chat. Hold on, there it is. So don't go right now, but you can head over there. I only got 25 copies, so if you don't have a printer, I'd probably get over there. But if you don't have a paper copy in front of you, just get out your Big Chief and write on a piece of paper. You're going to have it all on there, though, when you turn it in. When you submit, this is something you're going to submit. So anyway, I have all the problems here, but I think it was IO that had a request for number 16. And that's the gold standard. So that's probably one that other people have a question about. So I'm not going to work the whole thing for you, but I am going to kind of help you set it and answer your questions. How about that? Now notice each one of these tells you how many points they're worth. So that's worth 8 points. And you do get partial credit. Now, I will give you, hey Takaki, I noticed there's a problem with one of your submissions on your homework. So go back and check that again and resubmit something. It seemed like there was something that was missing. Anyway, check that. All right, so I will give you, when you turn this in on Sunday, when you submit this on Sunday at midnight, that's your latest chance to submit it, then you will, you'll get credit. I mean, unless I'm seeing a bunch of chicken scratches on here, I'm probably I'll spot check some things, but you might lose, you're gonna get most of the credit, okay? If you do this, you do it totally wrong, but obviously you thought about it, you're gonna get at least half credit, all right? Okay, so we go through the 10 steps and they're all kind of meshed together. So first thing I would do is we are recording this, yes. I would circle all the numbers and the units and then figure out what symbol each one is. I see I'm trying to end up in miles per hour. So that 330, that's my delta S. Because if you've ever taken the Heartland Flyer to Dallas, it's not a straight line. It's not like a Delta X, right? It curves around the rivers and stuff. It's a really cool train ride. But at the Hyperloop, they are proposing, if you read this sounds crazy, but they are proposing a Hyperloop eventually. One of those things that said 2030, now we're talking 2040, but the Hyperloop between Oklahoma City and Dallas. So they're saying 18 minutes. You could actually live in Oklahoma City and work in Dallas, or vice versa. This would be an 18-minute commute. That's the future you all will live in. Hopefully. All right, so time then is 18 minutes. Miles per hour, we're trying to find velocity. Okay, first two steps. So you got to do a little drawing, and that can be something simple, just maybe OKC, Dallas. You guys even know what a hyperloop is? Rose is shaking her head no. Let me tell you. All right, so you know in the bank, when you, like if you go to the drive-through in the bank and you put your money, you put your check in the little thing and then you hit the button and it zooms up, that's basically the hyperloop. But they would have a vacuumed out, it'd be like 95% vacuum chamber tube. That's why it's called a hyperloop. It's a tube that run, they already have these, by the way. They've already built these. Of course, Dubai is many years ahead of us. They've already got one either built or in the works. So we're even talking about a hyperloop under the ocean that connects up New York and Paris. So yeah, or New York and London. But this is one of those Elon Musk's back of the envelope, sitting around having a beer with buddies and come up with this idea, and then people took it and ran with it. And so there's a lot of companies working on hyperloops. It's going to be $1 billion industry, it turns out. But you get in a tube, and it's not you don't get your car in the tube. You sit in the tube, and then you got your luggage behind you, and it accelerates slowly. I don't think you can do more than 3 Gs worth of acceleration. It's too uncomfortable. Maybe 4 Gs, and then once it gets to speed, you're going at about 800 miles an hour. So that's how you can get from here to Dallas in 18 minutes. But this is not some science fiction thing. They actually have working models now. All right, prototypes they call them. So what else do you need on your drawing? You probably need, you just need symbols. I'm fine with that. So this is, because you don't have a lot of room there. This is delta S. V is what we're trying to find, right? Yeah, V is what we're trying to find. And then we know that our time, we know T. So that's enough for a drawing, okay? The symbol thoughts, we only have a couple of equations. Really, we only have one equation we've actually worked with much. And it turns out that's gonna be it. So we have delta S equals VT. Now you all are the best and the brightest of the best and the brightest because you're here on a Wednesday morning on your own. You volunteered to come in here. So feel free to ask questions. You're amongst friends, okay? Everyone in here is a hard worker. So they're looking for some free help on the take-home test, which either way, you're smart. So feel free to stop me anytime. This is supposed to be a back and forth, not just me talking to a screen. Now we get to V, and so yeah, interrupt me, please, or just comment. I'm looking, I'm watching for your comments up there. So I'm trying to find velocity. Well, you know, I know it's been a while, but algebra 1 here, we divide both sides by t. And so we have now the t's, get out my green kill pen, and the t's cancel there. And so we have P equals delta S over T. Yeah? Okay, so in this box goes delta S. In this box,
1 over T.
I was gonna try and fool you. Okay, Eric saved the day. 1 over T, right? Not T. A lot of students put T there. No, 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 no. 1 over T, because it's a fraction. So then you stick in what you got. We know we got 330 kilometers. over 1. We got 1 over, so we got 1 over 18 minutes. Okay, I'm going to make this a squiggly line. I don't know why I didn't do that. That's stupid. And from then on, it looks like it's all just conversions, clever forms of 1. Now, probably 4, maybe 4 slots. Now, what did I tell you? I told you the ones on the take-home test and the test are nowhere near as hard as that stinker number 3 we did yesterday. That was hard. This is, see, that was a preview of like January. But I wanted to show you a hard example so you could see what the most I could throw at you. But this is fairly, I know it's new to you, but it's fairly rough. Okay, I'm not going to finish it. You're going to finish it on your own, but it says, what's the average speed in miles per hour? So go ahead and put in the answer, put miles per hour. Now you know what you're trying to go after, right? You got to kill kilometers. I gave you 1.6 kilometers equals a mile. So I actually gave you the faster shortcut. 1.6 kilometers per mile. You got minutes into hours. Boom, boom. I think it's a 2 slaughter. These are slots. So this whole thing, when I say that, last thing, and I'll go on to something else, but this whole thing here is called a slot. And this little part is called a cell. So I'll say slots and cells. This is about a 2 or 3 slaughter at the most as far as conversions go. Okay? So that's as far as I'm going to go, but you can finish it up. Questions? Going once, going twice? Like I say, I'm recording this, so you can look this one up on the, look for this on the Facebook group under Unit 2. Unit 2 is where the take-home tests are. So I'll put this, not a wrap-up video, this help video there. Okay, somebody else give me a problem you want to look at.
Number 2.
Thank you. Now, Sophia already asked a question about number 2 in the Facebook. If you go to Unit 2, you'll see, and I answered her question, but I'm certainly willing to look at it here. So this one's worth 4 points. Use a label drawing and correct symbols to help you explain the difference between position, displacement, and distance. This is sort of what we were doing in the hallway. A lot of you lost a couple of points, or a point, or maybe 1 point on the last, on sheet 1.4, because you were giving me I roofs and J roofs on the distance, but distance is a scalar. Displacement, of course, is a vector. Position is really, position's kind of in between because it has I roofs and J roofs, but it's not an arrow. Yeah, it's not really, it's kind of an arrow. I mean, position's weird. Anyway, let's just look at it as an example. Let's say that I'm going from, say here's my, you always have to establish your origin. So here's my origin. And then let's say, I go two things. Let's say one, I'm going here, and then I'm going to go over here. So those are 2 positions. And if we go ahead and put over that whole thing, yeah. Okay, so let me put in the background a XY axis. That's close enough. Okay, so then we have to, okay, so we've established our origin. Well, then let's say this is at 5 meters, and this is at -3 meters. Well, if all I say is 5 meters, -3 meters, you don't know whether it's on the x-axis or on the y-axis, right? So I got to say 5 meters I roof, and here I got to say -3 meters J roof, right? That tells me where I'm at, what axis I'm on. So those are positions, okay? This is a position. And that's a position. So you go, well, is that a vector? No, it's a point, but it has to have the, it doesn't, okay. The only time you had to have I roof and J roof is if it's in the problem. Okay, we'll drive ourselves crazy if we're always having to say I roof, J roof, K roof on everything. So, I mean, about maybe 15% of the time I'll put I roofs and J roofs just to keep you honest. Okay, but a lot of times we don't do it. All right, so displacement then, if I'm going to go somewhere, if I'm going to go from one point to another point, that's displacement. Well, let's say I go from 2 meters I roof to 5 meters I roof. Okay, so this is my start. This is my start, not my origin. The origin is back there, but this is the start point for me, and this is the end point for me. Well, in that case, I have a vector between the two because that's my displacement vector. The displacement vector looks like that. So that's my delta x. And delta, because it's a change in x. I went from x final to x. This is x final. Okay, in that case, this is x final. This is x naught. So delta x is equal to x final minus x naught. I know this stuff seems trivial, but it's the more I teach physics, the more I realize you got to understand your foundation. It's kind of the foundation for kinematics. Anyway, so delta x then is going to be 3 meters I roof, because it tells me I went 3 meters on the in the positive direction on the x-axis. That's what 3 meters I roof tells me. All right. Now suppose I go from, so that's displacement. Well, then what's distance? Jacob said it's a bit of both, and I think he was meaning the position is a little bit vector, a little bit scalar.
Wouldn't distance be your total length?
Distance, good point. Distance is the length, and so it's not it's distance. Okay, length. If I say how far is it to Dallas, and I say it's 182 miles, that's how I used to live in Dallas. That's how far I was from Norman to my place. That I gave you far. I gave you I didn't say what direction it was. So distance is not so distance would go here. Yeah. So distance between those 2 points, let me get a better color here. Hold on, sorry, purple. All right. So distance is here, but that's just 3 meters. And you know what? There's not even a symbol for distance. That is 3 meters. Distance does not even get a letter. Little d, no. Little d stands for derivative. Delta x, no. Displacement has that. Distance gets no letter. It's just how far it is. Okay, so if that's kind of the idea of the difference between the three. Distance is simply a scalar. Distance is a scalar. Scalar. Okay. Does that help? I mean, I suppose that you could just parrot this back to me and, handwrite it. But I'd rather you come up with your own examples, but okay, I mean, you'll get credit for it. Better for you to come up with your own example. Okay, other questions?
Could you do number 13?
Which one?
13.
13. 13, okay. 13, it says I'm not going to write the whole thing out, but I'll give you some kind of guidelines here. Does answer in at least 30 words. So 30 words is simply a long paragraph. Or you don't need, here's the cool thing about physics essays. Sometimes it can just be a labeled drawing with good labels. It can be bullet points. It doesn't have to be, like, you don't have to have a thesis statement and all that stuff, okay? I mean, I'd like you to write in the King's English, but you can do, you know, and I'm not going to count your words, okay? It just means that I'm giving you a feel for how long I want it. Sometimes it says, give me 100 words if it's a more complicated thing. Okay, so here we go. Worth 4 points. Answer using at least 30 words. Why is it sort of lying to leave a measured number using instruments? So suppose we measure it using our, say we just like we did with our timer, or say we use a meter stick or something. We measure a length, okay? And then we measure another length and we divide the two. We're doing X versus Y or something. We're doing slope, okay? Let's say that we're doing slope of a, we watched a cockroach crawl across a table, and I wanted to know what direction was that cockroach going. And so I looked, I put a dot where the cockroach started, and I put a dot where the cockroach ended. And then I took my little ruler and I measured it. I measured the X and I measured the Y. So then I got to divide the two, right? Slope is rise over run. But I actually measured it with a ruler. So let's say that in the X, I measured for that cockroach. I grew up with cockroaches, man, I know. And then let's say that direction was, whoop, hold it. Let's say that direction was this way, but now I measured, so this is, let's say it's, say this is 1.15 meter. Why am I making my numbers hard? Make them simple. I try and make simple numbers on tests. 1.5, I'll make it simpler than that. 2.0 meters, it's a big table. And let's say this is 3.0 meters. Okay, so I want to know what angle, let's say I want to know what the slope is. All right, so I divide them out. Well, I leave the slope as 2/3. And then the units would cancel, right? So the slope is 2/3. But that's a lie. Because 2/3 is 0.666666 repeating, right? So it's telling me, if I say 2/3, I'm saying that I use some kind of crazy laser that could be as accurate, that could be infinitely accurate, a theoretical laser. So I'm lying to the person. So I need to stay, instead of saying 0.666666 or 2/3, I've got to say 0. And there's 2 siggies on this, 0.67. And the units canceled, so that's it. 0.67 will be my answer. So the point is, when you're measuring things, that was a dumb example, but when you're measuring things, you can't just leave measured numbers. If you're dividing measured numbers, you can't just leave it in fractions. You have to go ahead and show the decimal, because otherwise you're kind of a liar. You didn't mean to be, and then you're going to get called on it by a good, by a good boss. So the example I gave there was 50 meters over 21 seconds. And if you just leave that as your answer, then you're not taking into account how accurate your meter stick was, or whatever you use for the 50 meters. And you're not taking into account how accurate your timer was, because this is going to give me an infinite number of siggies. And I can't have that. So because you're not going to have that. So you have to actually divide them out to show how accurate, what is 50 divided by 21? What the, oh, can somebody help me out? My phone is 50 divided by 21. So dumb. Okay, now I get it.
2.34.
You got what again? Hold on. I got it. You said, hold it. I can't hear you. 50 divided by 21. That's going to be, yeah, 2.38. Okay, so that answer is 2.38095,238. Well, is that what I'm saying? It's that many, that's the speed now, meters per second, or is it 2.4? Is it 2.38? Is it 2.381? Question mark, question mark, question mark. I don't know. So you're not being forthcoming by leaving it as a fraction. You're not telling your accuracy. Thank you, Jake. Okay, well, that's the idea. So see, that was my essay answer. Now, if you did this for me, I would need a little bit more. Maybe, I mean, I might, if I'm grading this, let's say this is your paper and I'm grading on a test, then I might come along and I go, heck, I'm going, question mark. What do you mean by that? And you get, I see what you're saying, but I need to see more than this. Talk about instruments somewhere. I'm using instruments, so therefore, you'd probably get a 2 out of 4 if you left it like that. So you need some words in there. Okay. What else we got? There's some metric questions, but that's all just power line stuff. That's all from sheet 1.3. So I think you could do that okay. You probably ought to take, you know what you ought to do? If you're willing to social distance, you ought to go to, we always went on Saturday mornings to, hopefully we'll go again one day, but to Stella Nova's. The two popular places are Stella Nova's and Panera Bread. But Panera Bread's sort of D. Powell's. That's David Powell's territory. We occupy Stella Nova's on Saturday mornings. But now it is open, but you ought to go somewhere, maybe the library or something, and as long as you kind of keep your distance from each other, wear your masks and all. Or just go on the Facebook and you can go to rooms and click on that. I think you can open up a video and you guys can talk that way, or do your own Zooms. You don't need me. You got some smart people in here. You guys got more intelligence than I do. What do you need to ask you for? Go do your own Zoom and then announce it on Facebook. Hey, I'm going to Zoom on Saturday morning. Who wants to come with me? And maybe it's just you, but you with the camera on you. But, you know, then you guys can talk. That's probably the best way to do it. Okay, so another question. In other words, you're not alone. You don't have to be. If you call a Zoom party and nobody shows up, no one's going to know that nobody showed up. That's their problem. All right, so what do you want to do? Or maybe you have no
4D.
questions. Which one?
Number 4D.
4D. Very specific. Okay, so 4, how about we just look at 4, and then we'll get to 4D. It says, write the physics equations for the following graphs representing bicyclists. Okay, so we got to figure out, let's look at 4D. It says that the bicyclist represented by the solid line rides in the same direction for a total of 35 hours. What will be her final displacement from the group's origin? Now, obviously, this is some kind of average velocity because she'd have to stop and eat and go to the bathroom and stuff, but you're looking at an average velocity. Okay, so let's just concentrate on the solid line then. Solid line is this one. Okay. So let's blow it up a little bit. So let's get an equation for that line. So everybody, I'm going to give you a minute because I doubt you've all worked this test yet. You're probably just starting it. So let me give you a minute to you come up with the equation for this line. Boy, I'll set mine up, but you do it too. You do it yourself first. I'll carve out some space here. Okay. So you could call it Y if you want. I'm going to go ahead and call it X. X versus T. And so we're going to have an X of T equals. First thing I do, I always go for low-hanging fruit. I go for the easy stuff first. Gives me a feeling of confidence. Makes it feel like I did something. So I go ahead and just write in where it started, right? That's the easy thing. So minus 40 kilometers. Now somebody asked me, do we need to put I roofs and J roofs on there? I'm not going to count off if you do, but notice in the problem, nowhere does it talk about I roof and J roof. So if it's not in the problem, it doesn't need to be in your answer, okay? But I'm certainly not going to count off if you do, unless you do it wrong. Okay, I'm just looking at who's here. Why don't you all give yourself, everybody give themselves 5 Zoom points. So just between me and you all, everybody gets 5 Zoom points. Now, Zoom points, Facebook points that I'm given, I gave Rylan 10 because he showed us a little thing on how to work something, how to record the screen. But Zoom points, Facebook points, those points you accumulate, and you got to keep track of them. And then you don't cash those in unless you need them. So if you're sitting at a 89.1 in December, then you go, hey, Mr. Askey, here's proof that I've got 25 Zoom points. And you told me you gotta log all this stuff. You told me on September the 22nd or 23rd, whatever it is, that I got 5 Zoom points. Okay, so you log all that, and I'll give those to you. Then that gives you the A. See what I'm saying? Same with Facebook points. I can't keep track of all those, but you call me on it if you need them. All right. I mean, if you got a 98 average in here, then you don't really need them. Well, so what? You got an A anyway. All right, here we go. Now we got to find the slope. So the slope is the rise of a run. And notice that slope, I can find that anywhere. I could do it here to here, but that's going to give me bad data. So no, that's not that it's saying it's wrong. It's just that let's be a little more accurate than that. So I try and find a place where it's crossing. You can go all the way to the end and all the way up. I'm just going to go this far where it's crossing a grid, okay? Because it's all the same. It's all the same slope. So that's 60 kilometers. And that's, what is it, 6 hours. So my slope is 60 divided by 6, or 10, right? So it's 10 kilometers per hour. Stop me if I'm wrong. I make the dumbest mistakes possible. Times T. Everybody agree? Thumbs up. You can always put the little icon on your picture or something. Okay, so we're not done though. That at least sets the equation up. So now we have our equation over here on D.
Mr. Askey,
Yeah.
I got something different for the slope.
What'd you get?
I got 9.38.
Let me take a look here.
Well, what I did was I went to the very top, right?
Okay, so you went to 80. You went to 100 and wait. You went to 120.
Yeah.
You did 120 over 16.
Yeah.
Oh, I think maybe you're right. Hold on. Where did I mess up at? It shouldn't matter where you go, right? 120 over 16. Why aren't we getting the same slope?
It would be
It's not 120 meters
It would be
or
160.
kilometers. It's 160.
There's still that negative.
Oh, well, it's going by 20, right? It's going by 20. Oh, see, I fell for my own stupid trick. That's dangerous, and thank you for that. Wow. I didn't go the entire delta x. I started at 0, boom. All right, thank you. So that's me making a mistake in real time. 160 divided by 16, it should still be 10. I'm starting to freak out there a little bit. All right, so back to this then. So I'm going to write it out again. So we have x of t equals 10 kilometers per hour times t minus 40 kilometers. Okay, so I don't need the graph anymore. So it says you stick in 35 hours. Oh, that worked out nicely. A lot of times though, on a test, I'll say like 120 minutes. So you got to remember oh wait, that means 2 hours. So be careful on that one. I haven't written the test yet, but I know that's in there somewhere. So I stick a 35 hours in here. It's already in the right unit, so we're good. So you punch that in, and somebody tell me or comment what the answer, if I punch in 35 there, what do I get for an answer?
310.
310? I get an amen on that? 310, right? Okay, 310 kilometers. But now, do I have to go back and mess around with it? Here's where this gets confusing, because that's 310. Is that okay? So then the next question might be, if I'm trying to fool you, maybe the next question is, how far did that bicyclist ride? How far did the bicyclist ride? What do you say?
350?
Right. So she rode 300, and watch out for this on the test. She rode 350 kilometers. But but when you write the equation is in reference to the origin. That's a subtle point. But she rode 350 kilometers, but from the position of the origin, for some reason, these three people wanted to make the origin that 0 point. Maybe that's Gaylord Stadium or something, and they're doing everything in reference to Gaylord Stadium. So in reference to that, she went 310 kilometers away from that. But in reality, she rode 350 kilometers. Okay. All right. Another question. I figure you can get the equations for the other ones, but what else we got? We still got 17 minutes left.
Do you want us to show our work, like on number D, like how
Yes,
you did?
this would be enough work right here.
Okay. Okay.
And for me, work is an equation, and your opening equation should have units in it. And then if it's like here, I can just punch it into my calculator and boom, I have an answer, right? So then give the answer, and then I'd be happy with this. I'd be happy in this one for work if you just showed this, maybe stuck that in there and showed that. That's it. Okay.
Okay.
Can you do 16?
All right. Who else has a question? More graphing on 3. 3, they give you the equation and you got to write the graph. 4, you're given the graph, you go write the equation. That's sort of a theme for packet 1, it looks like. Okay, yeah, we talked about number 1 enough. You should have notes on that, or you can go back and look. You know, it's not cheating to go back and look at the screenshots. I want you to go back and look at the screenshots. And by the way, I'm going to post a key to this. A nice, neatly, won't be all sloppy, a nice, neatly written out key. But that will not go up until like 3 days after it's due. So that if somebody came along and say they weren't being totally honest, and you guys are mostly 95% of you are pretty honest, really honest. But let's say that there's some desperate students come along and they wait until the key is posted and then they turn their take-home test in. It's legal to do that, but you're going to lose at least 30%. You're going to get the best you're going to get is a 70% on that if you do that. Whereas if you turn it in on time, and even though you're wrong on some problems, but you got through all the spot checks, you might get 100% on it. Whereas that person turned it in 3 days late and was perfect and get a 70% on it. See what I'm saying? So I'm trying to be fair to the kid that gave it a shot and turned it in on Sunday night, even though they weren't sure they were right, then the kid that waits till Wednesday to turn it in. Okay, life in 2020 here with all the, so we're cool, I guess, on the metrics. You don't want to see one of those worked? You guys are fine, really? You're fine on 14 and 15? Doesn't bother you at all? Now this is the first half, and normally the first part, 1A, the A part of the take-home test is not that hard. Not as hard. The B part on the take-home test is the harder one. So that's a coming next week. Oh, by the way, write this down. Fairly new information here. Test 1. We're talking 300 points. And it is going to be on October 13th. One way or another, I don't know whether it's virtual or what, but we're going to have a daggone test, on a real test on October 13th. Hopefully we'll all be, except for virtual, and virtual I'll do through Zoom, but hopefully you'll be sitting in the classroom and we'll just be, you get the hour to take it, right? So I think that's a Tuesday. I was going to do it on the 8th, but that is fall break. So I'll be down in Austin. So on the 13th is the date. But have no fear. If you understand take-home test 1A and take-home test 1B, and you've worked it out on your own, you've made your mistakes, and you've checked the key, and you've talked to each other, you're going to blow away that test. And you get those, rack in those 300 points. And then, you know, the rest is gravy, man. All other points are trivial. I mean, the packet's worth 100 points. That's quite a bit. Your notes are worth some points, but really it's all about that test. Now, if you bomb, say you just can't do tests, you just hate doing tests, and you bomb this test, then you can get some points back. There's ways to get, it's called blue and black points. You can get like half credit back on some things, sometimes full credit back. If I felt like the test question was unfair, that's called a black question. You get black points back on those, but we'll discuss that later. Okay, who else has a question? 15? You still got 11 minutes.
I haven't gotten to that yet, so.
Oh, okay. Well, that's probably true. Well, then if you haven't got to a question, just look at them and go, oh man, it's going to be trouble. So which one do you want to work, even if you haven't got to it? Hold on. I didn't hear that one.
Can we work through number 15?
15, yeah. Okay. 15. So that may take us to the end here. 15, okay, so it says, you end up at a point, and this is like the hallway stuff we did, and I apologize to virtual kids because I know you weren't in the hallway. I videotaped myself in the hallway doing some of this stuff. So go back and watch that wrap-up video from last week. I think it was Friday or something. Anyway, you end up at a point in the hall just in front of Mr. Shader's room, which is about 12 eye roof meters. After you've walked eastward using baby steps, so that's a slow walk, at half a meter per second eye roof for 30 seconds. Notice here, check this out. This upsets students, but notice here and here. So far, I've written this. It can be written either way. It can be written as 12.0 meters eye roof, or you can write it as 12.0 eye roof meters. You see it both ways, it doesn't matter, okay? All right, so, sorry, they're cutting the yard out there. For 30 seconds, okay, so there's my T. This is my X final. This is my V, okay? Write the equation for your slow walk. So we already kind of have a lot of stuff here. So we say, okay, it's X, because it's eye roof, right? So it's X. It's X of T equals, now we know we're going to do the general form VT plus X naught. Well, I'm a low-hanging fruit guy, so plus 12, I'll just write it the way I wrote it, 12.0 eye roof meters, okay? And then I got to put my velocity in there. Okay, that's 0.5 eye roof meters per second times T plus 12. And here's where students are going to mess up. They're going to put the 30 seconds in for the T. No, no, no. I'll make a note here. So that, yes, that goes there, but do not put it in there. If I put 30 seconds in for the T, I'm giving you 1 point. I'm giving you 1 point on my graph. I'm not giving you the equation. You've got to, this has to be a variable. That has to be a variable. That T does. Okay, I'm going to use that 30 seconds, but then because now I got to plot it. So it says plot this. So I go down here and I say, all right, I know I'm going to go 30 seconds. I know that I have 12 is my initial. Whoa, really?
12 is your final point.
Oh. Oh. Oh, man. See, I was going for the low-hanging fruit, but I didn't read the question. You got to read. I wrote the daggone question. I didn't read it. My final position is 12 eye roof meters. So what this is saying is that at 30 seconds, so I can use my equation again. I obviously haven't written the key yet. I wrote this question a couple years ago. So what I'm saying is it's 12, my answer. And whoever piped in and told me that, you give yourself a couple of Zoom points. So we're saying 12 eye roof meters is equal to 0.5. See how the eye roof gets irritating? Eye roof meters per second. That's why I don't do it that often. Times 30 seconds. Plus, now it'll give me my X naught. That'll give me my initial position. So let's go ahead and do that. So we got, that says 12, just go just to numbers now. Just do pure math here, arithmetic. 12 equals now 0.5 times 30 plus x naught. So therefore, x naught equals, whoa. So that's 15. So x naught equals -3, right? -3 meters I roof. Okay, now I go back and do it the right way. And this is minus 3, I'll do it the way I was doing it there, 3 I roof meters. Or you can say 3 meters I roof, doesn't matter. Now, now we can easily plot this. So, you know, remember I told you to make mistakes every day? I make mistakes every day. Because now I made that mistake on a take-home test, no harm done. I won't make the mistake. I won't make that mistake again on the test when it really counts, when the problem is all of a sudden worth 30 points. Okay, so we got -3, and so that's going to put me right there to begin with. I go at a half for 30 seconds, so I'm going to end up at, well, I already know where I end up at. I wrote where I ended up at. So 12 in 30 seconds, end up here. Then all I got to do is connect that up. Well, that was a fun problem. I'm not crazy about my line, but all right. Thicken that up a little bit. But, ooh. Boom. You see, it's better. If I could do a magic wand, I'd give you guys all an iPad. And probably the school district will come through in about 2024 and buy an iPad. But it makes it, then you don't have to use pencil and paper at that point. That's kind of nice. You turn everything in to make PDFs. You can capture the page and send it in. Anywho, so there it is. That's done. I'm down to 4 minutes. Maybe time to start one more. One last one. Now 14 is about the same. 14 is the same, just in the J roof, right? 14 is in the Y-axis. So maybe, well, it's fresh in your mind. Maybe knock off 14 real quick. Then it doesn't leave you a whole lot to do. I mean, all of these right here are pretty fast. Should we do, we have time to do one of these. Let's do one of these. Let's go with let's come down here and let's do the hardest one. But I'm going to go with the hardest one. Let's look at number 12, let's say, okay? Last one. What you got to remember to do. Last one, 12. How many terameters are in 4.62 times 10 to the 8th millimeters? Okay, so I'm going to write it out the way I normally write it out, so I can play the game. 4.62 times 10 to the 8th millimeters equals blank terameters. So I play the game now. 8, I'm going to keep that. Milli is -3. Tera is +12. I add up the powers on the left. I subtract the power on the right. So 8 minus 3 is 5. Minus 12 is -7. So my answer is 4.62 times 10 to the -7. Right? Now I'm shell-shocked from that last problem. Did I just make another dumb mistake, or am I right? Thumbs up. You can just put the thumbs up icon.
I think that's right.
Well, Jackie's got 1 vote of confidence. Jacob, Okay, so if Jackie and Jacob both agree with me, then I think I'm right. And Aspen says yes. So I'm feeling good now. So that's how you do those, all right? You can use and someone asked a couple days ago, will we get that power line on a test? And the answer is yes. You'll always have that, or it'll be hanging in the seat, but you'll always have it, okay? All right, well, I think this was a productive hour. Maybe the most productive hour we've had all year.
I have a question over 4D.
We did 4D. Let's go back and look at it, though.
Wouldn't you add 4D instead of subtracting 4D since you're finding displacement?
Displacement, okay, so good question. So what we're looking at is what's our final displacement? So but it says from the group's origin. So displacement is delta x, but it's in reference to the group's origin. So it's saying, so in this case it's x final, but in reference to the origin minus 0, because the origin's at 0, right? So x final then would be 310. So x final is 310 kilometers, right? So if we're looking at delta x from where she started, that would be 310 kilometers minus a minus 40 kilometers, and that would be 350 kilometers. See that? That would be another, that's in reference to her starting position. So really it's two ways of saying delta x. One is from her starting position, and one is from the group's reference point.
Where did the 310 come from?
310 comes from this equation. If I plug in,
Okay.
yes, if I plug in 30, these are good questions, Aspen. If I plug in 35 hours into the time, this is always in reference to the group's origin, not to her origin. Now, coincidentally, she might be starting at the group's origin, but maybe not. She wasn't in this case. Those are those little ticky-tack things that bug students. All right, well, I've gone too far. I'm going to now, I know it's recording. Please tell me it's recording. But I'm going to now put this recording, it may take me a little while, but I'm going to put this recording onto the Facebook group somehow. I can't put it in YouTube. Anyway, we'll figure it out. So it'll go on my Facebook group. I suppose, what we could have done is I hate to do this, but I probably could have told Sophia and Rose and Takaki and stuff to turn off their cameras. Too late now. But if I tell you guys to turn off the cameras, then I don't see why. There's not a FERPA violation, So anyway, because I want your cameras on, but forget it. Too late now. So I'll just go ahead and put this somehow. This will go, I know what I'll do. I'll download it onto my computer, and then I'll stick it onto the Facebook. We'll figure it out. All right. Thank you all. That was a fun time. As you can tell, I love doing physics. It's my life. So you're never bothering me. I have an ocean of patience for honest to goodness questions, and sometimes the simplest question that you think is dumb, it all of a sudden changes everything. It's like, oh my gosh, I've improved my teaching by your questions. Like at the very end, I forget who asked, I'm sorry, but you were saying, can you talk about that 4B again? Let's look at that again. And that made me go back and think, okay, I'm saying delta X, but that's not obvious because you could look at it different ways. So I love your questions. Thank you. That's how I feed off. That's how I get energy from you guys, is from your questions. All right. I will see you guys. Be back tomorrow for first hour and third hour, and then Friday for second hour. We're going to work on mostly 1.6. 1.6, the back. That's all circular motion. That's brand new stuff. So we'll develop a new equation or two. All right. Good. So Jacob says we are recording. That's good news. I'll see you guys. See you on Facebook. You can always ask your questions on Facebook 24/7.